Lesson 10-2, Series. A series is the sum of a sequence. So it's just taking the terms of a sequence and adding them together. A sequence might be 2, 4, 6, 8. So the series would be 2 plus 4 plus 6 plus 8. Now if the sequence is long, then the series could also be very long, and it'd be a nice way to write it shorter. So we have what's called summation notation or sigma notation, because this E-looking thing is actually the Greek letter sigma. The letter down here is called the index, and it is the variable that is changing. The number that it equals is the lower limit and is the number you start with. And what you do is you plug that into the index variable there. So we end up with A1 and then A2 and A3. And so then you put a plus and then the next one, a plus and then the next one until you plug in the upper limit. So continue until we have AN. Find each sum. So here's one. All right, so what we can do is it says I equals 1 at the bottom. So we're going to start by plugging in a 1 for the I. So it'll be 4 times 1 plus the 1. And then you put a big plus, and we repeat using the next number. So it'll be 4 times 2 plus 1. Put a plus, and then the next number would plug in a 3. 4 times 3 plus 1. Put a big plus, and then the next number, 4 times 4 plus 1. And we stop there because we have now plugged in our upper limit. So all you have to do next is simplify. So this will be 5, that's 9, that's 13, and 17, which gives you 44. Or we could try this one. Our lower limit is 2. So we start by plugging in a 2. So it'll be 2 plus 2 cubed plus, plug in the next number, which is a 3, plus, plug in the next number, which is a 4, plus, plug in the next number, which is a 5, and then we stop because we've hit our upper limit. Notice we stopped when we've plugged in a 5, not when we put 5 terms. We only have 4 terms here. But you stop when you plug in the upper limit, the 5 in this case. Simplify, so the first thing is 10, and then it's 27 plus 2, and then 64 plus 2, and 125 plus 2. And all those add together to make 232. All right, this one is interesting because it says that the upper limit is infinity. So this could take a very, very, very long time. So with these kind, it might be easiest to find what are called partial sums. So first one, just plug in a 1, and that gives me 0.5. Then maybe I could plug in the 1 and a 2. And that gives me 0.5 plus 0.05, which is 0.55. And then maybe we could plug in a 1 and a 2 and a 3, which is 0.5 plus 0.05 plus 0.005, which gives you 0.555. try plugging in the 4. So we have the 1, the 2, the 3, and the 4. To be 0.5 plus 0.05 plus 0.005 plus 0.0005, which gives you 0.5555. And so now we could say, what is our pattern? The pattern is it approaches, appears to be 0.55555, repeating, right? Which turns out to be 5/9. There are some shortcut formulas. If you add 1s, 1 plus 1 plus 1 plus 1 plus 1, from 1 through n, so we're starting at 1 and we go through n, it just equals n. Go 1 plus 2 plus 2 plus 4, so that's the sum of I from 1 through n. It's n times n plus 1 over 2. And these are perfect squares. 1 squared plus 2 squared plus 3 squared plus 4 squared. So it's the sum of I squared equals n times n plus 1 times 2n plus 1 all over 6. Here's some more special formulas. These are cubes. This is 1 cubed, 2 cubed, 3 cubed, 4 cubed. So this is I cubed. This one's I to the 4th. And I to the 5th. So we would use these by taking our summations and splitting them apart into these units, as we'll see in our next example. All right, so let's evaluate this. Remember, we're adding here. The order we add doesn't matter. I could do 3i squared minus 5i plus 2 squared minus 5 times 2 plus 3 squared minus 5 times 3. Or we could do all the 3i squareds and then all the 5i squareds and then combine those. So we could rewrite this as 3i squared minus the sum of minus 5i. Sorry, we already had the minus, so it would just be 5i. Well, we could also factor all of the first ones would have 3 times the I squared. So it would be 3 times 1 squared plus 3 times 2 squared plus 3 times 3 squared plus... So we could factor out the 3. And the second part is 5 times I, so it would be 5 times 1 plus 5 times 2 plus 5 times 3. So we could factor out the 5. And now, that's a shortcut formula. If we look back, that would be n times n plus 1, 2n plus 1, all over 6. And that's a formula. That one was n times n plus 1 over 2. Oh, but it's not n. What was on top? So n is 5. So plug in a 5 for the n. And run it through your calculator, simplify it, and I think you end up with 90. That's all for today. Have a good day.